like a T. What does this T signify? Perpendicularity. So it has defined a perpendicular relationship between this line and this line. And that is why it's giving out the warning. So what we need to do is we are saying, no, we don't want that perpendicular relationship. We want to delete that perpendicular relationship. So just click on this, click on that icon, that perpendicular icon. That perpendicular icon is the one you have here, right? So click on it over here and hit delete on your keyboard. The moment you hit delete, it's going to be done. So that means that constraint has been removed. And now we can change the angle to whatsoever we want. So I'm going to dimension again. And then I'm going to make this line to this line. And the angle is going to be 150. It works now. So for those of us that have that issue, have we been able to resolve it? All right, so that's great. So the second thing I said we need to dimension, we need to tell Fusion how far is this line from the center, right? So let me find out, and then I will let you know. All right, so the distance from this horizontal line to our center, or what we call the origin. Okay, no, I said the origin 0,0. So the same thing as our center. It's going to be 11.25. If I remember that again, I just forgot what I read now. Okay, 11.25. Yes, that's correct. So start my dimension tool. You want to go from this line, all right, to this origin. Just bring it out. It's telling me for me it's currently 16 point something. So I click and I change it to 11.25. And then it brings it down like this. All right, so now it looks like the design got worse. How many of you have your design turned like this? Your design turned to something like this. All right. But can you still see a small horizontal line? You can still see the small, and it's not crossing each other. The two, it's crossing each other. All right, so this is what you do. Press Ctrl Z 2 times. Press Ctrl Z 2 times, it's going to bring you back here. So what happens is that when we are trying to change the length, the gap from the horizontal line to the origin, it was bringing that line down and it was reducing the length of the horizontal line. So let's tell it first what we need the length of the horizontal line to be before we change the gap. Okay. So let's find out what's the length of this horizontal line. 26. So dimension, click on your dimension, click on this line. Pass your dimension to, click on this line. Move it to a position you are comfortable with. Click, and I'll change it to 26. Have we all done that? Have you done that? All right. So now that we've changed it to 26, we can now change that gap, the 11.25 dimension we did the other time. So how do we do that? We click on the line, we want the gap between the line and this origin. Move your cursor out, position the dimension, change this to 11.25. And now you can see the line is not going into each other anymore. Did it work? All right. Did it work? Yes or no? You having issues over constraint sketch? Speak to him. He's going to fix it for you. How many of us have gotten this to work? Okay, if you're having issues, please raise your hand so that we sort that out. So what's the issue like? This is meant to be 150. Danny, what did you do to this thing? So dimension is less. Dimension is angle as well. So now change the gap between here and here to 11.25. Is it working? Yeah, it's working. Yeah, good. I'll show you the last thing. So just leave it straight. Good. Who else is having issues? We're all good. You're good. All right, what's the issue?
From the 26, I'm not getting this one and this line.
So you start your dimension too. You want the dimension from this line to, okay, you want the length of this line, right? So now you bring it down. I'll change it to 26. Now working. You then close this one from this, then draw a line. They draw a line from here to yes. Forgot that. Change the dimension of this. Change this angle to 152. And then you change the gap between these lines and this to 11.25. Sorry. Any issue? Over constraint sketch. Let me see. So that means you've introduced an extra dimension. Oh, Jesus. I need to do okay. So this is 150, this is 150. And it's 77. Why is it not moving? This angle is 150, this angle is 150, this line. Right. So which of them is it? This the length of this has 26.
Even like a back.
All right, so I can see that. I can see there's already a dimension.
Oh,
Yes,
I didn't see that. You click on that.
but then you dropped it somewhere.
Yeah.
So if you zoom out, escape. You can see it's over here. So bring it back, drag it back.
You drag it.
Yeah. See, drag this thing. Drag it back. Just change that to 26. Anybody else having issues? Keep on coming.
This line is
Yes, understand. We'll fix that. No, there's no but. Just add the angle 150 degrees. All right, so I think almost everybody's good. And so we'll continue now. All right, so you would have taken notes. Some of you have seen that this line, one of these inclined lines is shorter than the other one, right? And it looks like this is not at the center. This horizontal line is not centered. All right. So now we want to center that horizontal line. Who has an idea of how we can do that? Using what? Using dimensions. So how will I use dimensions? So let me show you how you can use dimensions to center it. Now you said the length of this line is 26, Abi. So if I want it to be centered, that means from this edge, if I'm measuring horizontally to the center, it's going to be what? If the whole length is 26, from this edge to the center is going to be what? 13. You get that? Can you clap for yourself? You get that? Oh, you guys are not happy with clapping. Don't worry. I'll start asking you to do like this for yourself. So start your dimension again, but now you don't click on the line. You click on this point, the corner, or the vertex. Is that okay? So click on that vertex. Can you see this vertex? How many of us can see that vertex? We all can see this, right? So make sure you click on that vertex. So that means you're trying to see from this point to the center, horizontally. I want it to be 13 millimeters. And now it's centered. The two inclined lines have the same length. How many of us have that result already? Has everyone been able to center it? Can we proceed? I have an issue. Can I see your hand? Okay, we all good. So now, this is good. Okay.
That's I'm not getting it.
So you want to go from this dot to corner. Don't click on the line. Don't see this white dot. All right. So that's the vertex. The moment you see the dots, right? If it's not seen it very well, just zoom in. All right. Now you can see it bigger. Press escape. Your dimension from this dot, right? So this origin. Actually clicking on the line. All right, let's do that again. Formation. Let's do the one from this dot. This dot. All right, change that to 13. So make sure you're just clicking on the vertex. Don't click on a line. Click on a line. Oh. So the dimension from this dot to the center, that is halfway. For you, your dimension is as 20. So it's going to be halfway, that will be 10. So then put some 10 over there. All right, so I believe majority of us have been able to center this. Okay. Now you see we have a lot of dimensions already, and they are cluttering our screen. We can hardly figure out which one is which, Shibi. So the way you can hide this dimension, so that they're not cluttering your screen, is come to your sketch palette. Can you see something called sketch palette on the right? All right. Many people tend to abuse this thing I'm about to show you, and now they will be having issues. So I will tell you how to use it very well, so that it doesn't affect your work. So come to this sketch palette. You see something called dimensions. Can you see a checkbox in front of it? So if you uncheck that, it's going to hide all the dimensions, so that you can just see the outline of your design. So this is what we have so far. All right, we can see it very clearly. So what is missing here? Let's see the original design. We are looking at it from the underside. Okay, we should have another arc here. We should have another line, small line here, and then another small line here, and another horizontal line. Can you see that? So let's see how we can get that to work. So the moment you turn off your dimension, make sure, capital letters, make sure, like compulsory, make sure you turn it back on, all right? Only turn it off for visualization. If you continue designing like this, you will get into trouble, all right? So make sure you turn the dimensions, check, make sure it is checked before you continue. So to get this smaller arc I have over here, now you can see that this arc is not the same thing as this arc that was coming over here, all right? It's kind of smaller. So how do I get that arc? Now let me find out what the dimension of that arc is. All right, so the diameter of this arc is 61, but apart from the fact that the diameter is 61, the gap between this arc and this arc is, right now I've forgotten what I just measured. Let me find out again. So the gap between this arc and this arc is 12. Right? That means if you go like this, you go inside like this, the gap between those two of them is 12. Are you sure you get what I'm saying? So let me draw a circle. So this is the bigger arc, right? And then you have the smaller arc. So I'm saying the gap between this, in this way, is 12. Is that okay? And the diameter is 60 something. So how can I tell friction? I need another circle. But I need the gap between that circle and this one to be 12. So we make use of what we call offset. Can we say offset? Offset. So offset means you have a geometry over here, maybe a line, but you want to create a copy of that geometry at a distance from the original one. Are we getting that? So we want to create a copy of this circle, but we don't want it to be at the same position as the circle. We want the circumference to come inside a little bit. Is that clear? So we're going to use what we call offset. How do I create an offset? Come to your modify panel. You expand it, you find a tool called offset. What is the shortcut? O. So if you press O on your keyboard, you will start the offset tool. So click on offset, click on this bigger arc, all right, this bigger circle, drag it inwards, all right, and then you can see as you are dragging it, the dimension is increasing. So let's just change that to 12. Now it's going outside, so instead of 12, I'm going to say minus 12, so that I can go inside. So once you have minus 12 there, click on OK. All right, and I can see we have a circle that has a gap of 12 millimeters from the bigger one. Have we been able to do that? Great. You guys are getting it very fast. You still the server as plus. You already told me you don't like the plus. So I'll stop asking you to unplug yourself. Now we need to offset two other things. Can you see this line? This line is parallel to this line. Chibi? Actually, this line is also an offset of this line. Okay, that's what he means. This line is a copy of this line, but it's at a distance. Okay, is at a specified distance from this original line. So I'm going to create an offset of this line and an offset of this line. So go back to my design, click on offset. I want to offset this one. And then I want to, now it's going to take the three lines together. Can you see that? So just drag it inwards. So we won't be able to do minus 12 here. We'll do minus 5. Are we good? So once you've done that, press enter. At this point, you are done with the sketch of the base. Offset, this offset is 5 mm. The gap is 5 mm. The first one is 12 mm. Are you done? Who else is having issues? You are done? Over there. You're done? Okay. Busy. Are you done? Okay, thank you. So I told you we are done with this particular sketch. So once you are done with the 2D drawing, what do we do? What button do we press? Finish sketch. So once you are done with the 2D drawing, now I want to create a 3D object out of it. We'll click on finish sketch. So once you're done, click on finish sketch. All right, so we can continue. So again, click on the home icon so that it takes you to a 3-dimensional perspective. Click on finish sketch. All right, so make sure you come to your view cube, click on this home icon so that you're not seeing an orthographic view, you're seeing a 3D view of the object. Now, once you create a 3D object from this, and we are still going to be using extrude, we are creating a prism of that base area. So click on your extrude tool. Have you clicked on your extrude tool? Okay, press escape first. So you can see that there are different areas on this sketch. This is one area, all right? This is another area. All these spaces that you can highlight in blue, they are different areas that you can actually create 3D objects from. Are you getting that? So these areas, we call them profiles. That's the technical name for it. So we don't call them areas, they are called profiles. So I have a lot of profiles here. I have profile 1, profile 2, profile 3, 4, 5, 6, 7. I have like 8 profiles. But I don't need to create a solid model out of all those profiles. Just like what we did the other time. We need one space to be empty, to be an hole, yeah? Z and hole, whatever. So you need one of those spaces to be empty. So the same thing we're going to do here. We don't need all of these profiles for the solid one to create with, so we just need to select some of them. So click on the extrude tool. And to create this body, we need this profile. We need this profile. We need this profile. We need this profile. And we need this profile. We don't need the other profiles. Okay. Once you click on that, drag this arm up. And now you want to specify the thickness. How thick should this be? So this is if you're looking over here, all right? This is like around 5 millimeters thick. So just punch in 5 and press enter.
So, Right. Since you go, you go as securities. So that's what they do. No, sure.
So do we all have the solid object now? All right, that's good. It's coming to attention. So now we've all created a bit of the issue. All right, good. So we've all created a 3D object, all right? But then because the 3D object, you can look at it from different views, okay? You can look at it from the front, you can look at it from the top, you can look at it from the side. So if you need to look at this from the top, can you see your view cube over here? I can see something called right? If I click on that right, that means I'm now looking at the right view. The right view just looks like very straight. Now, how do you turn this thing around so that you can look at it from different angles? So you do what we call 3D orbits. Can we say 3D orbits?
Well, this is what Zoom is allowing us to accept.
So now how do you orbit your 3D model so that you can look at it from different sides? Come down over here. Can you see something called orbit? So click on orbit. So once you click on orbit, just drag around in the screen, and then it's going to turn the object around. All right. This one is something else you have to practice to get perfect about it. Okay. So dragging this smooth because I've been dragging this for a very long time. So are we able to orbit it? All right, so that's great. So come down to this toolbar, click on the orbit, and then you can drag the object around. So that's how you create a 3D orbit. Did you get that? Okay, I'm coming. You have a challenge. Okay. Beacon on him once it's done. Beacon on it. All right, so for those of you that have a mouse, all right, there's a better way you can even orbit. So instead of coming down here, so click on this orbit tool and turn it around. So press escape. I need to hold down the shift button on your keyboard. Hold down the shift button on your keyboard. Now there's a button on the mouse wheel. So press that button down. The moment you press that button down, you can see your cursor has changed. It has changed to the orbit cursor. And now you can drag around. Okay, the front, the back, the sides. Extra. You have a mouse. Yeah, so this is for people that have a mouse. Then hold down the shift button on your keyboard. Go to your mouse wheel. There's a button on your mouse wheel. Press down the button once. Make sure you're holding it. Hold down that button, hold the button down, and then you drag it around. Okay, so that's that about that. So let's do the last thing. So what we've done so far is we've created this, this area where you have the flange. Okay, and now you want to create this part that comes out, right? So, but let's make sure everybody's ready, and then we'll proceed from there. And that will be our last step for this particular part for today. Five mm. You want to? On this? This is not going to create because it will allow this line to touch this line. Okay. So don't worry, I'll fix it for you. So that's why I ask you always watch out for that cross before you clip. Right, and then you shoulder this one outside instead of inside. It should be -5. -5. 21 down. Do your extrude again. Don't forget to click. Who else is having an issue before we continue? Don't extrude, right? So I told you, click on this to go to a 3D view. Now go to extrude. So, all right, so click on the areas to extrude. Yeah. One after the other. Okay, so 3, 4, and then the outer one. This one, yeah, this, yeah. I can drag everything up. So make that 5 mm thick. Right, so let's go to the next step. We need to draw this part that comes up. Now click on, if you have to draw this part, now we are done with this base. What do you still need to draw? We still need to draw a circle, right? Yeah, but then it's a circle with different size. So let's go ahead. So want to do a 2D drawing now. What do I click on? Create sketch. All right, so that means you're getting this. So now you notice every time I click on create sketch, you can see that the object we drew, it was drawn on this plane, all right? And then we started extruding from that plane. That's where the height of the object started. But this one that we want to draw here now, where is it starting from? It's not starting from the bottom. It's starting from the surface of this. Do you notice that? All right. So how do I tell Fusion, okay, I want you to start this drawing. I don't want you to start it on that plane. I want you to start it on the surface of this solid. Please make sure you're following. This is very important. So you don't click on this plane in this case, because you don't want your sketch to start from there. You don't want your extrude to start from the plane. You want your extrude to start from this surface. All right. So make sure you are looking, something that is close to the top. Make sure you can see this top. And then when you click on create sketch, click on the surface of this object instead. Click on the surface of this body. All right, very important. Click on the surface of this body. Just click once. And then it's going to bring you to the sketch environment. Have you all been able to do that? Responsive? You've been able to do that? We need to create a sketch for this, right? That means we need to create another two-dimensional drawing, a 2D drawing. Now I'm saying when you are creating this 2D drawing, because the object you want to extrude is not starting from the plane, it's not starting from the bottom here. It's starting from the surface of this one that we just finished drawing. It's starting from the surface. So you don't click on the plane again, you click on this surface, on this face, the face of the body we just extruded. So click on that face, and it's going to bring you to the sketch environment. It's not working? Not working. What's it going to help you? Has it worked over there? All right. Right, this is what they need to do. Right, they need to click on start sketch, create sketch, but they should not click on any plane. You are meant to click on the surface of this body, on the face of this. It's going to bring it here. Does it work? All right, so we said we are drawing circles, right? And so you remember the diameter of our inner circle from our last sketch is 77. So we draw that same 77 again. Circle, start from the origin, make the diameter 77. So you can see this circle aligns very well. Okay, 77. This circle aligns with the body we just extruded. And then we draw a second circle. Again, make sure you're starting from the origin. Now make the diameter of this one 81. Well, let's make it 82. We're going to pick the size like that. So now you should have two circles. So now, who knows why we are drawing two circles? Why are we drawing two circles? The thickness of the wall. Start for yourself, even if the rest doesn't want to. Please clap for him. All right, so we are drawing two circles because this is the only profile we're going to be interested in. We're just trying to draw this wall. Okay. So by drawing that two circles, you have this region that you can extrude. And that's the wall thickness. So that's everything we need to draw here. We just need to draw those two circles. And then once you're done drawing them, click on finish sketch. All right, so you click on finish sketch. Go back to a 3D perspective. Remember to do that. Come to your view cube, click on this home icon. Now you don't need to do that every time. I just showed you how to do a 3D orbit, right? So instead of coming here and clicking on the home icon, you can actually just click on your orbit and then do a 3D orbit to a view you are comfortable with. Okay, it doesn't have to be the home icon. That's basically what the home icon is also trying to do. So just get your orbit to do a 3D orbit, and then you'll be fine. All right, so once you get to a 3D view, what do we need to do next? We need to create an extrude, all right? We need to create an extrusion of that profile. So click on your extrude tool. But before you do that, let me find out what the height of this should be. All right, so we're going to be extruding 52 millimeters tall. So click on your extrude tool. And then now you want to make sure you're clicking on this profile, okay? You can see there are now two profiles here. There's one here, there's one that represents the wall of this. So make sure you click on that profile, drag this arrow up slightly, change the value to 52. You said? The extrude height is 52 millimeters. So are we all done? Are you done? All right. So now you have created the base profile, all right? So there are just some final touches we need to make on that to make it look exactly like this. But we're going to pause here today, all right? And then we'll finish it up tomorrow. But now you can see what you have here, what you just designed, looks so much like what is over here, all right? So why is it different? Okay, our own wall is not as thick as the wall here. Okay, that's because we use 81 as the outer diameter. So we can just go back to that sketch and make it bigger. So let me show you how to go back to that sketch and make it bigger. So when you're using other softwares, you know, and you've taken a step and you make a mistake, you need to go back. What do? Control what? Control Z. You keep clicking on Control Z. No, it's not the same thing with Fusion. Fusion captures every step of your design process so that you can go back to the things you've done previously, make modifications to that feature, and then your entire design is going to update. Are you following me? So how do you make that change to your design? So I'm going to show you just one way of doing that today. What did I call the name of this place? When I was telling you the name of the party last time. I'm in this area. Yeah, I said this is your timeline, right? So your timeline is where your design steps are captured, okay? It captures your design steps. And now if you look, if I go just one step back, you can see I created a sketch before extruding. Now look at the icon of this on my timeline. Does this look like the icon of the sketch tool? This over here. Does it look like this icon? Yes. The last thing we did was we performed an extrude. This icon here, does it look like the extrude icon? Yes. So everything that we've been doing, it has actually been capturing it from the beginning. The first thing is that we created the sketch, we did an extrude, we created another sketch, we did an extrude in another sketch, and then another extrude. So we're going to modify one of the sketches now. So go back to this sketch, the one just immediately before the last extrude. Yeah, double click on it. Click on it 2 times, or you right click and click on edit sketch. So I want the thickness of the wall to be bigger. So I'm going to change this from 82. Let me change it to 87. It doesn't look bad. Change it to 90. So just double click on that dimension, change it to 90. Have you all changed that? Yes, all right. Once you're done, click on finish sketch. So once you're done changing this to 90, click on your finish sketch again. And now look at what happens. Can you see this is now thicker than what we had initially? All right. We didn't have to do the extrude again. We just have to go back to our sketch and change the dimension there. Does that make sense? All right, so at this point, you are on your journey to becoming an expert in computer design. So I think you deserve a round of applause. All right. Hmm? You went upside down. Okay, lock. Press escape. Press escape. All right. Now, once you go wire like this, just come back here and click on home. So home is going to take it to the sensible position. Click on the home icon. Sir? Thickness. Have you changed? Have you gone to the sketch and change it? Right, so go to your last sketch. This is the sketch. Double click on it, or right click on it and click on edit sketch. And then you go back and just change where you have 82, change it to 90. Design. Connect to your hotspot. Yeah, we need a review on that. The brief review. All right, so at this point, we have successfully designed two parts on the robotic arm. Which one and which one? The base and what? And the gripper link, okay? So we're going to continue with this tomorrow over the next 2 or 3 days. And by the end of that 3 days, we'll almost be done with the entire design. So what we're also going to be doing tomorrow is we're going to be taking what you designed on your computer, be taking it out of your computer, and we'll be taking it through the 3D printing process, okay? So tomorrow we're going to be learning about how do you convert your design from Fusion 360 to something that you can send to a 3D printer, right? And we're actually going to be designing the parts that we just created now. Is that exciting? All right. So please, what I need you to do is when you get home, right? You will not sleep tonight. You will do a video. You do a video on Fusion 360. So I want you to get simple objects in your house, all right? Things like your doorknob, all right? They are simple. Just look like simple objects that are as simple as what we've just done today. Circles and lines. Try and design them. Try and create 3D models of them. Is that okay? So you're going to make mistakes. You are going to correct yourself. And that is actually how you get to learn. You understand? So don't just go home and sleep. All right? Make sure you go and do something about this. Go and explore the environment. Go and try different designs out for yourself. All right, so that will be it for Fusion today. And before we end this session, so we research, the A platform for you that we're using for you is building the robotic arm from scratch, right? I've already started with that. So just to show more light on this kind of concept, right? So what you have here is a very, very simplified version of where you need to use a different industrial application. Okay. So this is just a small part. So this technology will going to come for you, right? And it's not going to really pick up place your way of doing. But this is a step forward in learning what goes to building those kind of systems. And when you see this robotic, I'm really like, okay, where we need this kind of thing? What do you want to use this kind of robotic arm for? Or what is the benefit of acquiring skills that require to build this kind of robotic system? So just to mention an example of the industrial application can be that you have design or you use to learn this kind of thing. So what the space called this area? Say is the gripper. Are you following me? Did you hear anyone that's called end effector? Did you hear anything called end effector? I believe it's something like that. All right. So this gripper is called an end effector. All right. This end effector technically is not a robotic arm. Are you following me? I'm trying to explain the usefulness of this. The robotic arm itself This end effector can be anything. It can be a paper just like the other thing, right? Let's say you need a robotic arm to perform well on an assembly line. The paper is not going to be sorry, the end effector is not going to be a paper. What's it going to be? It's going to be a welding equipment, right? A welding tool, right? You need the robot to do the bolting and just pick those and those apart. What is going to be? It's going to be good, yeah, like in partner that can actually do things or type the codes and on unexpected. If you need a paper to okay, if you need any effector to keep package together, how many of us know what's the name? Phone guy. How many of you know phone guy? How many of you know Julia? So we have an idea of how many packages Julia has to process every single day. Every single day, how many packages will Julia need to process their warehouse? Like 200 a week. Like how many? Let's go run out. Like millions. Okay, it's not 10 million. So you need to go process orders in thousands. And usually that process is going to be very, very simple. So the point is that stage that is at the point you will have actually go to the point where you will not be able to answer the amount of orders. So at that point, you need motivation. You need system planning. So I'm showing you an example. Another robot system that looks like this. For us, it's different than you do with different. So this is also dynamic robot, and it's like GHL. How many of you use GHL?
And a lot of we want to be on the forefront of that. So whenever there's an opportunity for us to utilize that within our operations, we want to be able to be more efficient, be more cost conservative, and utilize that technology in order to make us the number one employer of choice.
So the stretch system is made to be deployed relatively quickly, low infrastructure. And so from the time stretch arrives in your facility until the time you're moving your first box, this is only a couple days.
Stretch takes pictures of the box at the container, and the survey comes to the box at the time. The place is on the day, the box down, the box stays total, and the HMIC, which is short, there's all.
So stretch is a pallet size footprint. That means anywhere in the room, you can make stretch. It can move in omnidirectional, so it can move left, right, forward, back, go in circles. It has an arm that has a 6.5 foot extended reach or a 10-foot vertical reach. Information what it's doing is modeling them and the robot if you go pick them on. The only amount of pitch infrastructure or the side panels here.
So what's different with this stretch? What different
Workers to fund
the health sector? Okay, what the health sector of interest? What does it look like?
The box drives when it's inside the container, it continues to things on the external environment, it makes some adjustments and picks that box up and continues to move forward.
Right, what's the net effect on the stretch? How do you get the result out? They have something like a vacuum sorter, okay, good. All right, so the end effect is actually a function device, right? A vacuum sorter, so the function device is called the vacuum, right? So for that report, they are basically changing the end effect. So the application of the robotic arm is kind of vast, right? Depending on where you want to do them. In fact, what we see happen every day that people are designing different effectors depending on their use case. They are using it and maybe the pharmaceutical, right? Maybe different effectors for manipulating the formula that are processed. Are you getting it? So when you think of any process that requires automation, right? Now we said in Nigeria we need outside people to unknown people for us. So that's the automated using technology. So when you think of any system that it just involves manipulating function of some type, then you need something like a robot function to get that kind of process. Are you following that? Are you getting it? So the applications are processed. Take your one thing. This paper of it itself, what the business of the show is actually beyond the paper. It can be any other, correct? As long as it's my piece of it, I was going to say something. Yeah, with Nigeria. So I'm already started explaining applications of this Nigeria to you, right? So maybe if you have a chance to work with Nigeria or something like that, you need to create that. Right? You already acquiring skills that are relevant for your business. And how many of you know you have automobile in Nigeria? Maybe okay, we have in Nigeria. What that one? I think we have like we have laws. Okay, I think we have another one. There's one that manufactures military vehicles. Then they so I'm just trying to say you have like this is the Nigeria. And then I was recently I found out that acquired I don't know how many robots they acquired. So before their manufacturing process, when they are carrying the new commands into the way they can accept. Now they have robots in their facility to accept. Okay. So now everything acquired robots, right? They need robots for their head. When the robots be working by themselves, so they need people to support from their side. They need people to maintain the robots. What is going to do your make their process, not just buying them and putting them there, in them start again. They need engineers that down that time, what is happening in their I will that. So this is just very much like what we're going to do. So in the next couple of days, we are just planning acquiring skills and this kind of system. And when you are outside the industry, just have to deal with what you can, okay? The same skills you are acquiring here, you can use them to do something entirely different. The most important thing is understanding the fundamental system. All right. So can we clap for our simple, elegant, robotic power? So at this point, we are done with our addition for today. We will tomorrow. But tomorrow you're going to be working on the right. You guys like that. Tomorrow you're going to be working on the microcontroller, right? The processing aspect of your report. You're going to be working on that 25 reports per hour. So you want to think how to read the programs that are running on this program on this computer. You want to change for that. How do you think the sensor you have to buy and then you want to start and buy way down. You want to you are not ready, I can take you without so much time. So you don't come to so finally, before you go, they have come to depend on the because when you say we're going to be giving you what you need to set up your plan for finance and also for the network. So
What's that here?
it's not like I'm going to move on.
Are you with 6?
Like, she's like,
To get